Hello everyone. So today I'm going to talk about solar power system. My name is Billy and you can call me Willian. I'm a Bachelor of Engineering in Electricals Engineering, which is in Mechatronics Engineering. So first of all, I explain the objectives of these presentations, and then I will explain to you the major components, the major component in solar power system, and the calculation of power and tips and tricks when implementing the system. So please do note that this is not an educational video, and this is just for doing the hobby, and do this at your own risk. So first of all, starting with objective, there are four main objectives in these presentations. The first one is to explain the components of the solar power system in details. In this part, I'm going to explain the most basic components in the solar power system. The second is I'll talk about the calculation of power, which is how you calculate power and why you need to calculate power. The third one is the limitation of the system. And fourth one is the tips and tricks when you're going to implement the real system. First of all, let me show you the major components in the solar power system. So as you can see here, this is the most basic element. I would say the most basic element components in the solar power system. First of all, you need a solar panel, which is a PV. So I will explain in details the function of each component. So you need a solar panel and control and connect to the solar charge controller. In this case, a solar charge controller is a brain of the whole system. It's the brain of the whole system, and I will explain further later what is the function of solar charge controller. And then the solar charge controller is also connected to a battery. Because we know that energy cannot be vanished and energy can only be transferred. So extra energy is stored in the solar battery. And then the battery is connected to the inverter. The inverter is a device that actually converts DC to the AC. And then after that, the inverter is connected to the circuit breaker, which is the fuse, and then to your unit, which is your AC load. First of all, I will explain photovoltaic, which is PV. So this is the scientific name. So most of us will know it. We will know the PV as the PV is known as a solar panel. So what it does is that it uses sunlight as a source of energy to generate direct current electricity. So basically, it just converts the light energy into another electric energy in DC. So mostly in the market, there are two variations of the solar panel you can find. The first one is 12 volt variations, in which it gives a 12 volt DC current, DC. And then the second is the 24 volt DC variations. So we need to properly choose between these two variations. And why you need to properly choose these two variations? Because it's going to affect how you design your system. For example, if you are using a 12 volt system, that means you connected it into the 12 volt battery. But if you are using a 24 volt solar panel, you need a 24 volt battery. So there is a problem. In the market, there are no 24 volt battery. I mean, it's not common. So what you need to do is that you need to connect two 12 volt paired battery in series in order to get 24 volt. And also you need to select the solar charge controller that support 24 volt if you are using 24 volt. And that is basically when you are selecting a proper solar panel. The second element that I'm going to explain is the inverter. So inverter is basically just a device. So it's just a box or a device in which it converts the direct current, which is DC, to an alternative current, AC. So as I mentioned earlier, the solar panel will only give AC supply. DC supply. However, in our household, we are using AC outlet, which is alternating current. We have 24 volt in UK and Malaysia, and we have 120 volt. 110 volt, 120 volt, and 220 volt for China. So basically, we need a device to convert the DC into AC. So the device is actually an inverter, and this is the name of the device. The input is the battery, and the output is the AC volt plug. So we also need to note that each inverter they have their own power rating. So the lot we are using cannot be more than the power rating, or else it will burn the circuit. And I will explain further how you can calculate power so that you don't burn the inverter. The third element that I would like to explain here is the brain of the system, which is the solar charge controller. The charge controller actually prevents batteries from being overcharged and prevent the batteries from discharging through the solar panel array at night. So we know in the day we have sunlight. When we have sunlight, we can generate electricity. We can generate electric power. So the electric power will actually accumulate or store in the battery. So when there's night, when it's night, we don't have any sunlight, and it will stop generating the electric power. The electric current. So because it don't have a valve, so the current will just flow back to the solar panel, and that it will damage your solar panel. It will burn your solar panel because it's a negative flow back current. So in order to prevent these situations from happening, we need a solar charge controller. So you can imagine it as a valve. So the function of valve in our body is to prevent the flow back of blood, so that it won't flow back to our heart. It just pumps in one direction. So same as the solar charge controller. Besides that, it also have a lot of function. For example, like prevent of overcharging. When battery it have the capacity. So when the capacity when it's full, we cannot when the battery is full, we cannot put more current into it, or else I will burn the battery. It is called as overcharge. So high-end solar charge controller also have short circuit protections, and also to convert a 12 volt DC to 5 volt DC for the use of USB, as you can see in the pictures. It has a USB hub in which you can use it to charge your phone, 5 volt. You can convert the 12 volt to the 5 volt. It has an integrated circuit like LM7805 in it to convert the current, the voltage. And that is basically what I would like to say the most basic components in solar power system. So next, we will look into the power calculations. So there are a lot of ways to calculate power, but in this case, we are using just one formula. And the formula is power is equals to I times V. So from the formula, we know that power is the product of current and voltage. And power is calculated in watt, W. So another two formula is just the alteration of formula, which is you change the positions of I and V, and then you change the positions of V and I to get power. So here's come the problems. The questions why we need to calculate power. So we need to calculate power because when we wanted to buy products, and components, for example, the inverter, we need to know the power rating of the inverter and what you are going to use for the inverter. So for instance, you are using a television. So if the television is 2000 watt, the power ratings of the television is 2000 watt. So the inverter need to be able to supply more than 2000 watt to the televisions in order not to burn the inverters. So we need to protect our circuit. We need to protect our circuit, and we need to protect our components, because in solar components, everything is expensive. So that is why we need to calculate power. And how we calculate power is actually, in this example, we can see it tells you that the power of a 200 It needs you to calculate the power of a 230 volt televisions that draws a current of 2.5 amperes. So you can highlight here, the keyword here is 230 volt, and the current is 2.5 amperes. We know that electrical power is the product of current and voltage. So by multiplying the current and voltage, we get 575 watt. So let's say that if the television is connected to the power inverters, we need to make sure that the power rating of the inverter is more than 600 watt. So the power is only 575, but why we need a power rating of inverter that is more than 600 watt? So first of all, we need to calculate the loss in travels. That means the loss in travel, that means you are connecting extension wires, you are connecting a fuse, or you are connecting to circuit breakers, or you are connecting to another things. There's internal circuit that cause a lot of resistance, and that resistance actually consumes powers. We need to expect a more power than that in order to protect our circuits. So here it's relevant that I put it is more than 600 watt in order to protect the inverters. And that is basically the power calculations. Next, I'll go to the tips and tricks when you wanted to implement the system. The first one I would like to say is the most important one, is the proper wire management, and do not expose the wire. So we know the solar system, we are going to implement it outside our house, and it's not covered in anything, in canvas or not covered. So there might be, so when it's raining, it's exposed to the surrounding. So what you need to do in order to protect the circuit is that you need to have a proper wire management. You need to really cover the wire and don't let the wire to expose to the surroundings. For example, if there's water, if it is exposed to water, so it actually cause a short circuit. So you need to properly cover the wire. And proper wire management, that means maybe you fix everything using cable ties or cable box, so someone would not step on it. And then the next one is to use the fuse. So this is the must, to use a fuse or a circuit breaker to provide overcurrent protections. So in this case, because you're always you are doing this on your own and you don't have a professional guidance, so it is a good idea to have a fuse, because when everything, for example, you short the positive and negative terminal, or you didn't connect it properly, so it will cause an overcurrent, or we call it short circuit. So what happened to short circuit is actually, if you don't have a fuse, it will run a high current to your circuit, and then it will burn the whole system. So in order to prevent that, we need a fuse or circuit breaker. For example, if the circuit fuse is rated as 10 ampere, so when the current is more than 10 ampere, you will actually break the fuse. It will break the fuse and stop the current to flowing to the whole circuit, and protect your circuit from damage. And then the third one is that you need to know your energy requirement, just like I mentioned earlier. You need to put everything to calculations of power. You need to make sure that your load is not more than the power you supply. The fourth one is that you need to make sure each connection is tight and the connectors are properly crimped. That means you clip your connectors, and then you put your connectors into the terminals, you screw it properly, because we don't want any loose connections. So any loose connection will cause spark, will cause fires, and that is very dangerous. And then the next one is you need to know the worst case scenario. Here the worst case scenario, there are a lot when designing. For example, they will have a short circuit because maybe some hardware failure or anything so there will be a short circuit. So the short circuit is your worst case scenario. and you need to do a preventions to avoid the worst case scenario, to counter the worst case scenario. So when there is short circuit, you need to put a fuse. You know there is a risk of short circuit. To put a fuse to protect your circuit from overcurrent protections. The last one is regarding to cost, which is cost benefit analysis. So we need to take cost and benefits. You need to take the balance of the ratios of cost and benefits. So we know in solar, everything is so expensive. You have the solar panel, you have the inverters, you have the solar charge controller, and everything. All of this is very expensive. So you would like to implement solar power system because you want to decrease the electric bill. So you need to consider, is your investment into your investment into the solar power system, can it cover the electric bill? So before implementing that, you need to think of it, because when you start to invest in it, believe me, it will be a lot of money, because a solar panel is really expensive. And that's all for our presentations for today. So if you have any questions or any things you wanted to ask me, so please leave your comment in the comment box and I will answer to that. Thank you very much.